In this video, I want to present the concept of voltage, and to do this I'm going to use an analogy with water. Let's take a garden hose that's showed in green, and at the end of the garden hose let's add a nozzle that restricts the flow of water. At the left end of the garden hose let's have a piston. Now let's ask what happens when I push the piston to the right. Well, what's going to happen is we're going to get a water flow out the nozzle. This water flow is analogous to the movement of charge or current. This restriction that the nozzle causes in the water flow is analogous to electrical resistance. It resists the flow. This piston on the left side exerts a pressure on the water that forces it to the right. The pressure caused by this piston is analogous to electrical voltage that we'll call V. Let me erase this. Let's continue with our water analogy. The green shows a pipe that's filled with water. This orange shows a water pump with a handle that we can crank. And the harder we crank this pump, the more water flows within this pipe. Now here we have a restriction in the pipe that reduces the flow of the water. And this we'll call resistance R, electrical resistance in the analogy. Let's say that we crank this pump. We've caused a certain flow. And this pump is analogous to voltage in a circuit. It creates an electrical pressure that causes the current to flow. Now as we crank this, we could say we crank with 1 volt. We're turning it kind of slowly. Now as we speed up cranking it harder and harder, perhaps we crank it at 2 volts of pressure and we get an increase in flow. We crank it really hard, we have 4 volts of electrical pressure and the current flows even harder, even more. In electronics, we would call this a circuit. We have a source of energy, we have a current flow, and we have a resistor load. If we were to draw the electrical equivalent of this circuit, for the pump, we would have a battery. This is the symbol for a battery. This is the plus terminal, this is the minus terminal. And the pipe is like a wire, and at the right side we have a resistor. This is a symbol for resistance, and we have a wire connecting the resistor to the bottom of the battery. So the electrical equivalent is resistance R. We have a current flow in this wire, and we have a voltage that exerts an electrical pressure that causes the current to flow in the circuit.